Day 7, Car Audio School.
Like Tony Braxton said back in the day, this is day 7 of Car Audio School. This school will help you do your own install, become a technician at a shop, or if you're about that life, own your own shop at some point in the future. This is my online resume, and this is for entertainment and educational purposes only. And our goal here is to make sure that you can do it yourself and you don't have to go to a shop. So yesterday we talked about series and parallel, and kind of going backwards, we talked about Watt's law, we talked about Ohm's law, we talked about flow of electricity and all that good stuff. Today we are going to talk about DC and AC circuits. So what is important about DC circuits? So yesterday and the day before, we were talking about one-way highways for electricity to flow on, and we were series, and we were talking about parallel or multi-lane highways for electricity to flow down. Well, today's DC and AC conversation has a lot to do with that, and you'll kind of see how those things relate. And going forward, you'll start to notice how we're building upon previous topics or competencies to get an overall understanding of how all of this works together. So let's talk about DC currents first. So DC, think of it like a river flowing in one direction. Now, we've talked about that before. We've heard that before. And it's a steady flow of electrons in a single path, except for, in this case, we're going to talk about kind of power source, but specifically I'm talking about batteries. Batteries are a perfect DC source. So you can find this in your phones. You can find this in, watches, anything battery powered, RC cars. RC cars are a very good example of how an actual car works, but we'll get to that later because I'll go off on a tangent. But think of it like a flashlight or your phone. And then AC currents. Now, AC currents, if we're going to think about it in terms of water, we'll think about a ocean in the ebb and flow of water. They move back and forth, not just in one direction. AC is similar, basically, to the electrical power in your home. So your wall sockets are AC. A socket in your vehicle, if it has like an inverter to it, which is, inverter does a conversion of alternating current to DC current, or DC current to alternating current. And when we think about alternating current, we also have to think about your alternator. Your alternator is an AC device. Now, where this comes important, and it's a later conversation, but there's a thing called a rectifier inside of your alternator or your device that provides alternating current, and that flips that alternating current into a DC current that the vehicle can use, and that also charges the battery and holds up the charge inside the vehicle to keep it running. Now remember, the battery is only to start the vehicle. That's it. It's only to turn over the engine. Once the engine is started and the alternator takes over, that battery becomes a storage bank for your power for the rest of the vehicle. This is why when people do I'll say an alternator test. This is an easy way to do an alternator test, see if it's bad. Start the vehicle and take the negative off of the battery. If the vehicle stops, that means the alternator is bad, because the alternator should take over for the battery and start supplying the electrical current for the vehicle. Just a heads up on that. So I'll go over here to my other notes. So to understand DC current, or DC, and alternating current, AC, it's helpful first to grasp the basic concepts of electricity. The movement of electrons from one atom to another. This movement of electrons is what we call current. Now, current is the water, the flow of water. Current measured in units called amperes, or amps for short. For current to flow, this is back to our Ohm's law conversation, there must be a push provided by the voltage, which will say the water pump. We'll call that the battery. And this is just figurative because there is a water pump in the vehicle, but we're not talking about that. We're just talking about where the pressure comes from. And we'll call that the battery just to illustrate the push of the water electrons through all the electrical wiring. Push called volts. And then DC. So DC current is characterized by the flow of electric charge that is unidirectional. This means that the electrons consistently move in one direction within a circuit from a point of higher potential to a point of lower potential. So it's going to flow from the battery to, we'll call it the radio, even to keep it simple. And then from the radio to the speakers. With this being said, polarity. So DC has a constant polarity. It's either positive or negative. Fun fact, the electrons flow from negative to positive. This is why it's important to have great grounding techniques and we'll say termination techniques. So how you connect the wire to the battery and to the various other devices. And sorry about that. An image in the source illustrates a positive charge in a DC system remaining constant over time. There's also frequency in DC, or direct current. Since DC flows only in one direction and its polarity never alternates ever, has a frequency of 0 Hertz. We'll talk about Hertz in a minute, maybe tomorrow, but frequency is defined as the number of cycles per second. So cycles per second, there's a uptick, and then it crosses the line, and then there's a downtick, and these are equal. And once it gets back to the start of the line, we'll call that the horizon. That is 1 cycle. So it's talking about how many times it does that in 1 second, how many times it returns back to its point of start. Amplitude. DC has an amplitude component, which is its potential measured as voltage. So that is talking about how high it goes and how low it dips. The illustration shows that DC voltage stays the same over time. You can measure the voltage drops in DC circuits using a multimeter in DC volt mode. Oscilloscopes can also be used for DC signals, revealing glitches or unstable voltage trends over time, which is the advantage of a DMM or digital multimeter in some troubleshooting scenarios. So there's that. We're almost done. We still got to get to AC. And then sources and applications. Direct current is the electrical supply found in batteries such as 12-volt car batteries. It is the type of power that supplies energy to most electrical components. Even in hybrid and electric vehicles that utilize high voltage batteries, these are very high voltage batteries, the power stored is in DC. DC is also used for various scenarios in vehicles that reference battery voltage. I'll teach you how to do that later. You can measure DC current using a DC current clamp, often called a Hall effect clamp. I have one here. It's actually in my garage. I'm going to start bringing up tools when we get to tools, and I'll show you all the different types of tools that we can use to troubleshoot and take measurements in vehicles. Often a Hall effect clamp, which allows you to measure current without breaking the circuit. So what they're talking about there is usually you have to get in between that circuit to measure the voltage or current going through it. A Hall effect clamp, you can open it up and it basically clamps around that wire, and it'll read the current or voltage flowing through that wire, which without actually having to break it in half. We're at 12 minutes now, so I'll do another one for alternating current.